Alright, it's March 15th, and here comes another video on making an engine. We're messing with American V8 old school muscle car engines, which should work pretty good in NASCAR 2003. Anyway, the car for today, or for yesterday rather, was the Z28 Camaro with the 302 engine. And right now I want to actually take a look at the SS Coupe Camaro, which came with the 350 engine, and I will show you the reason why. What do we got? Our 350s right here. How much? 295 horsepower. That's about the one that I was looking at. There you go. Alright, so the reason why I want to take a look at this one is the cubic inch displacement. And even though the engine is called the 350, you could see that the actual displacement is 349.8. The reason why I am putting together this little spreadsheet with a couple of versions of different Chevy engines that I'm looking at for now. These are small blocks. There's gonna be 3 different versions of the 302 for testing, 3 versions of the 327, and 3 versions of the Chevy 350, just to compare and do our testings on, you know, what does what. You can split the engine part in 3 different sections. The power values and the RPM values right here, I'm gonna mark them in green for now. Engine dimensions, like the actual size of your engine and your pistons and crankshaft dimensions and that stuff. Intake valves, and then the rest. That's basically what I call it. It consists of the red line, peak power, which actually doesn't change a darn thing when you just mess with that value by itself, which is still under the research. This weird ass 2 unknown values. One of them is probably for the engine qualifying. And oil and water cooling. Basically, I'd say red line, oil and water cooling are the 3 important lines out of the last section. So I'm putting this little spreadsheet together, and I'll upload it for you in a Excel version and in just a picture, so anybody could take these dimensions right away and, you know, do your own testing, do your own comparison, you know, swap the little numbers back and forth just like you would swap parts in real life. Anyway, why did I want to look at the displacement of the 350 is because I'm inputting the cylinder displacement, and in my edit we're gonna be down to 0.1 accuracy, like it's gonna be in tenths of accuracy. It's not just gonna say 302, it's gonna be down to the actual displacement of the 301.6, 326.7 for the 327 Chevy. Those of you that are a little bit familiar with the engines are gonna know what I'm talking about. Now the engine displacement that I wanted is the 349.8 for the 350, and I'm just gonna input that one right there for later. Funny how it came out in different colors, but okay. Next step, number of cylinders. Well, we all know that for now it's all V8. I haven't done any V6 or 4-cylinder testing on this new engine theory. Number of intake valves. Well, all of them OHV design overhead valve only have 1 intake valve. That's quite simple. Now I'm putting another little PDF right here with the data for Chevy engines, and if you can see, let me zoom in. Yeah, there you go. Those engines came with 3 different sets of intake valve sizes: 172, 194, and 202. Those are the names. It's 3 different sizes. So for my engines, which actually, why am I doing 3 different ones for each size, is because they all came in different carburetor versions, different bolt-ons, so they all produced a range of horsepower. There wasn't just one rating. So the same 302 or the same 327 could have made a big difference, about 100 or 150 horsepower different depending on what you bolt onto it. So I'm gonna do research on, you know, the differences between the real life values, well, how it's going to be in game, and for that it's going to be 3 prototypes for each small block that we're messing with for now. So the difference is not only going to be in sizes of the valves, which I'm going to include 172 for one engine another one we're gonna run with the 194 heads, and another one we're gonna run with the 202 intake valves. And I'll repeat the same numbers for the rest of them, but they're also gonna vary on the RPM and torque. By the way, I'm gonna change it for everybody right here: BMEP1, BMEP2, BMEP3, because those are not torques, and I'll update the physics editor slowly with better definitions and then release an updated version for that as well. That's later on, but it is what needs to be done. These are BMEP values, these are not torques, so I don't want to confuse anybody anymore. And I'm gonna switch and go and call them like that from now on. If I still have them as torque, please remind me to change that, because that is incorrect. Anyway, so the variables are going to be not only in the intake size, intake valve sizes, that's going to limit our airflow in the engine, but it also going to depend on whatever torque curves that I get from the automotive catalog with different RPMs and power values. So will the red lines, and then the oil and cooling I will leave stock NASCAR 2003 for now, and then we will fine-tune those values depending on how much cooling an engine really needs. What else? For now, this would be the end of part 1. I'm gonna fill in the rest of the values right here, and that would conclude the part 1. Part 1 would be, or part 2.1 or 1.2, doesn't matter, is to get all of these dimensions. You want to know what is your engine, how big it is, what kind of stroke it has, what kind of bore it has, what kind of intake valves it has, how many cylinders it's got. You need to get your engine dimensions first before you input the power values, because those are not actually torque or horsepower, those are BMEP values. So the formulas are going to take the RPM, BMEP, calculate torque, calculate your bore, then calculate all the stuff and get your power rating, like, you know, the increasement of the power rating depending on how big and what kind of engine you're running. So this is very cool, so to say, compared to like just inputting the horsepower numbers. Anyway, I'm gonna stop right here and slap a second part of the video later on. So for now we got all of the engine dimensions done right here, and that's not too many. It's stroke, cylinder displacement, number of cylinders, number of intake valves, and intake valve size. Now I'll stop right here and watch for part 2. And in the final part of the video, I want to go a little bit forward and talk about the BMEP values, the torque, like the physics editor creator thought that those were, but those really the pressures that are exerted onto the piston area. So what do we get from NASCAR 2003's engine dimensions? We get the engine size, the cylinder displacement, then we get the stroke of each cylinder. That means once we put the pressure onto the piston, how far down it is going to provide the driving power, like how long is it going to travel down until it loses the power momentum, you know, and has to go up on the other stroke. Anyway, on this picture you could see at the bottom the piston is traveling all the way down, and that's how the stroke works. Basically it's up and down motion of the piston. That will define of how much air and fuel you could squeeze into each of the cylinders. Now, knowing the cylinder displacement, number of cylinders, and for now we're dealing with the V8, so it's 8 cylinders. So knowing the displacement and the cylinders, knowing the stroke, we could find the bore, basically the size of your cylinder from side to side, and that is a very important measurement. It's a self-calculated measurement, meaning you put these 3 values, 1, 2, 3, and the game calculates the bore by itself, fourth one, so you cannot mess up on your formulas. The game takes care of this value by itself. Now let's go and let me give you like a simple example. Our number of cylinders are going to be a V8. It's a little online calculator that I use. So we're looking for the bore. Let's say our stroke is 3 inches and our displacement is 302. Going back to the Z28 Camaro. And this thing will calculate our bore, and our bore will end up being 4 3/1000ths of an inch. You could safely input the bore value of 4. What else? Then let me go on Google, and we want to find area of a circle. We know that our bore is 4 inches, radius is half of the bore, so that's 2 inches. It is very easy. We input this into 2, and our piston area, or our bore area, is 12.57 square inches. Why? Because now, by doing all this calculation, the game engine knows exactly how big, or I mean how big the square area, the top area of our piston is. So now we can calculate the pressure times the area will equal the torque. And how much torque, or for how long is it going to be provided, is dictated by the engine stroke. So we basically got the size of the spark, the size of the heat, boom, you know, explosion happens and it's driving the piston down. And by using the stroke and the bore calculation, we also know how big our piston is. And that could be translated into horsepower if you apply RPM. That's for the next video. Once you get all these values, the area of the piston, the size of the bank, the stroke, and then once you comply all that with the RPM and plug it into a different formula, we can find our horsepower now. That is how the game engine finds the horsepower ratings. We do not get to input any of those. We do not get to input none of the torque values, none of the horsepower values. The game engine calculates it's all based on the size of the bank that we input, the BMEP pressure, and then the rest of the cylinder dimensions like the bore, stroke, and the size of the piston head. Anyway, might have been too confusing for everybody, but if you watch this video 2 or 3 times together with some other videos, I'm sure you can make some sense out of it. I'm gonna stop right here, not to make it too long, and in the next one we're gonna go forward with all this crap and get down to the horsepower ratings and how we can calculate our engine. Let's say it's making 200 torque at 3000 RPM and it's making 250 horsepower at 4000 RPM, for example. And then I'll show you how to input these numbers into the NASCAR values. Anyway, later for now. This one is quite long. What else? Just stay tuned, I guess. You know, the muscle mod is coming soon.